All right, we're going to go over some Cobb-Douglas today. Cobb-Douglas utility functions. So the way to know whether you're dealing with Cobb-Douglas or another utility function is to kind of look at, this specifically and see that, okay, if my variables are like right next to each other, if they're being multiplied by each other, then I know it's a Cobb-Douglas, okay? Like if it's like x times y, like that's like the most basic Cobb-Douglas. If utility function is equal to x times y, most basic. So that's why I know since f and h are being multiplied together, I know that this is a Cobb-Douglas. Plus, then you can be fancier. You can have like exponents in front of it. It just makes the deriving a bit more trickier, but it's fine. We'll be fine. So yeah, here we have the price of the food, that's F, is $10, and the price of housing, that's H, is $5. And our income that we're given is $150. And we're told to find the MRS. So how to find the MRS, right? When we have something as tricky as this, right? From class, you might have heard to take the partial derivative with respect to a certain variable, right? So now let's say that we're taking the partial derivative, right? Because this is like marginal utility of f over the marginal utility of h that we get. So when we're taking that, these subscripts really just mean your partial derivative that you're taking, right? We kind of ignore that h, right? When we're taking the partial derivative with respect to with respect to f, we ignore that h and we treat it as a constant. Take that derivative, right? Bring that 2 down, we get 20f, right? And then plug that h back in, because that was a constant, remember? So that's my 20fh. Over, now we take the partial derivative with respect to h, right? Take this as a constant. Make this whole thing, right? Treat this entire thing as a constant, okay? And that's the thing that we're deriving, right? So when we have a constant and we have we're deriving, like think of it as like, oh, 2x. What's the derivative of 2x? Oh, it's 2, where x is like my h. Think of it that way. So when you're deriving it, you just get 10f squared. That would be your marginal utility of h, right? So simplify all of that and you get 2h over f as my MRS. That really helps, right? That really helps because now we're also given our budget constraint. When we have our price and we have our income, we can just write down our budget constraint. That's 10f plus 5h is 150. And we have our MRS. What do we know to always do, right? We have to compare our MRS to our price ratio. Perfect. So one thing that we have to do, we have to really know is, what is this constraint optimization problem, right? This whole time, my previous video too, we were talking about how our constraint is our budget, right? Is our income, right? All the time, whenever we have our like utility, whenever we have our benefit, we always have to, at the end, plug back into our income because that is what our constraint is. Later on, it's going to be a little bit different in the future when you learn it. But now, right now, our what we plug back in is going to be always our constraint because that is our income. Our income is our constraint. Our objective, our goal is to maximize our utility, to maximize our benefit that we get. So this is how you write a constraint optimization problem, right? We maximize our utility such that this is what we have for our budget constraint. So know this. This might actually pop up on an exam. So just know that. Finally, we have our optimal bundle, right? Again, we take our MRS, so this is my MRS, right? This is my MRS, and then this is my price ratio. Again, where did I get the 10 and 5 from? Just the coefficients in front of our budget constraint. Just the coefficients, okay? Right, now what I do is just cross multiply, right? 2h times 5, and then f times 10. We get 10h and 10f. Cancel those 10s out, and we end up getting h is equal to f. That's really helpful, okay? When we're plugging back into our budget constraint, that is so helpful because we just plug in, right? Just imagine that f is my h, whatever, doesn't really matter. You could plug it here. You could plug This in here, it's the same thing, right? 10h plus 5h is equal to 150. Combine that and you get 15h is equal to 150, and h is equal to 10. Well, if I know h is 10, I know that f is 10 as well, because h and f are equal. So that gives us our optimal bundle. H and f, our optimal bundle is 10 and 10 of each. Okay, so that's how you do a Cobb-Douglas utility function problem, right? This is how you kind of find it when the variables are kind of connected, when they're multiplied. And so then, yeah, and you compare the MRS, and you compare the MRS to the price ratio. This is how you write a constrained optimization problem, and this would be your optimal bundle. Thank you.